Hey guys, welcome to today's stream, and today we are going to start equality comparisons and sameness. Uh, I can give you a TLDR for this because for actually these two, not objectives. I haven't used object is anytime, but like these are basically strict equality and loose equality. Strict equality also checks for types. So let's say we have a string of two and a number of two that would not be strictly equal, but that would be a loosely equal. So that's the whole TLDR for these tools, and uh, um, in my opinion, in what from what I know, but I there could be something more, but let's see. Let's also see what object is. Um, object.is. JavaScript, three different double equals performs type conversions when comparing two things and will handle not a number, minus zero and plus zero, especially in conform to not a number. So not a number not equals to not a number. Yeah, we saw that. And minus zero is equals to plus zero. That's also true. Triple equals to will do the same comparison as double equals, including the special handling of not a number, but without type comparison. If conversion, type conversion. If the type differs, false is it. Object is thus no type conversion and no special handling for not a number, minus zero and plus zero, giving it the same behavior as triple equals to, except for those special numerical values. Okay, now that's basically it. I don't think that should be a lot, but let's just see. Let's just go through it quickly. They correspond to three or four equality is loosely equal, is strictly equal, same value, same value zero, made by many built-in operation. Let's just see. Okay, these are ECMAScript documents. I actually didn't choose reading ECMAScript because that's like too verbose, let's say. Like it's just way too much, and it's better to have a knowledge that is actually like um for your level, let's say. I'm not currently at this level, at master level. It's okay. So yeah, but see, it's equal. So basically it's the same. So that's what they are trying to say. In simple words, we know that what strictly equal is, what loosely equal is. Um, strictly equal using triple S equals to new string and str equals to equal. No, so we know how this will work, how loose equals will work, and we also know how objective is will work. It will, like, for example, for minus zero and plus zero, it will give you like false, and so that's how it will work. And okay, um, comparing equality method. People often let's come to this. Same value zero equality. Similar to same value equality, but plus zero and minus zero are considered equal. Same value zero equality is not exposed as JavaScript API, but can be implemented with custom code. Exactly. If type of x is equals to number and type of y is equals to number, triple is equals to number, x and y are both equal, and maybe 0 minus 0, or they are both not a number. If basically if they are equal, then return true. And so this case will check for not a number, because not a number is not equals to not a number, and then uh, so and zero zero. So that's how it works. Like this case is for not a number. This is here plus minus zero. Uh, Same value zero only differs as with strict equality treating not a number as equivalent. The only differs and same value equality is treating my zero as equivalent to zero. This makes it usually have more sensible behavior during searching, especially when working with not a number is used. I thought protect includes that. Comparing equality methods. People often compare double equals and triple equals by saying one is an enhanced version of other. Yeah, that's what I have heard a lot. For example, double equals could be said as an extended version of triple equals. Yes, uh, though like a lot of people consider triple equals to be as an enhanced version of double equals, but yeah, I understand why they are saying so, because double equals or like automatically converts the type, so it does extra work, and that's why they are saying it's an advanced version. But I understand the point. Yeah, but in most use cases, is you need a triple equals, and that's why people uh, we usually consider triple equals to be a much advanced version. Yeah, so that's they are also basically saying that alternative it can be claimed that double equals is the baseline. However, this way of thinking implies that quality computation form a one-dimensional spectrum where totally strict lies on one end and totally loose lies on the other. The model fails short with object is because it isn't loose or where than double equals or stricter than triple equals, nor does it fit somewhere in between, being both stricter and double equals but looser than triple equals. We can see from the sameness comparison table below that due to the way object is handles not a number, notice that if not a object is not a number, not a number evaluates to false. We could say that it fits on the loose strict spectrum as an even stricter form of triple equals from one distinguishes between minus zero and plus zero. The not a number handling means that is untrue because unfortunately object thought is has to be thought in terms of specific characteristics rather than its looseness or strictness with regard to equality operator. And okay, let's just see. Undefined, all of them will be given true. Null, all of them will be given true. Uh, True, all of them will be false is equals to false. Foo, zero, zero. Basically, these are plus zeros. True. Plus and minus zero. So object is will give you false, and because object is does not handle plus and minus zero, and plus zero minus zero and zero. So this is actually plus zero. This is a syntactical sugar or plus zero. So that's why object is will give you false, and big integers zero and minus zero. Hmm, okay. Um, my guess was that object is should give it as a false because it's zero and minus zero, but in case of big integers, it has a different behavior. Um, cool. Zero and false. So double equals to will only give you true. Um, Empty string and false double equals will give you true. Empty string and zero double equals true. Zero double equals true. Double equals true. Okay. Uh, this is interesting. An array and a string double equals will give you true. String string double equals true. Null undefined double equals true. Null false. Double equals will also give everything will be false. Undefined false, everything will be false. Uh, if there are two objects, so in this case, the references are considered. So these are two completely different references. Therefore, every one will give you false. Same with like object of string, basically string object, and zero and null false, zero and not a number false, like string and not a number false, not a number and not a number. This object is handles, not a number. So uh, when to use object.is versus triple equals. In general, the only time object.is special behavior towards zero is likely to be an interest in the pursuit of certain meta-programming scheme, especially regarding property descriptor, when it is desired for your work to mirror some characteristic of object not defined property. If you use case does not require this, it is suggested to avoid object or is yeah, mostly like when these checks are being made, people just write if else statement. Like no one, I don't know anyone who uses object or this, but if you use it, it's actually a JavaScript internal API, and obviously it's actually better to use it because. But usually people write if else cases when they see such require such uh, structures. Even if your requirement involves having comparison between two not a number values related to, generally it is easier to special case of not a number checks. Exactly, that's what people do. Usually is not a number method available for previous version of ECMAScript, then this workout has surrounding computation might affect the sign of any zeros you encounter in comparison. Here's a non-exhaustive list of built-in methods that an operator that might cause distinction between minus zero and plus zero to manifest in your code. In negation, yeah. If object or velocity is zero or computes to zero and a minus zero is introduced at the place, the sorry, I have some cold also, so I'm a bit sleepy today. Um, so all these functions, mat.flow, mat.max, and sign will affect object caveat. Object dot is and not a number. Object dot is specialization treats all instances of not a number as same object. However, since typed array are available, we can have distinct floating point representation of not a number which don't have identical behave identical in all conditions. For example, okay, f to be, it's a function. It gives you a floating 64 array buffer. B2f is also a function which gives you a different buffer. Const n is close to f to be not a number. N of 0 is close to 1. Then 2 is close to b2f n also log not number. That's why that they're saying, basically they are saying both not the numbers are different, and um, that's why like that's a caveat when you're using object.s, both are not a number, but and that's why we the not a numbers don't uh, like comparison of the two not numbers give you false because of this case. This is a problem when you're using object orders. It's actually very like most people like as they also mentioned, most people will not use object order. Is they'll just make if else case. Let's see, should we do this today or not? Seems small, but I have a bit of cold and if it's greater than 10 minutes, I'll just leave, I guess. Because my eyes are red. Uh, yeah, it's difficult. I thought to like restart my lead code series also today, but it was very difficult for me. Um, to speaking is difficult. Solving is not that difficult. And I also have some other work that I did, so it's not that I'm wasting my time or anything. But yeah, this is very small. I don't feel uh, very good like leaving it at 12 minutes because that's very small. But yeah, let's end it here. And thank you for joining. Let's end this name. Bye bye.